Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Before you proceed, I kind of like to request our members also to subscribe, engage us in the comment section, and also ring that notification bell to be getting various updates on different topics in math and sciences. Now, in this particular discussion, we're going to look at the last members of the S and B block elements. And this is going to constitute the noble elements of group 8, which of course have listed at the far end of our representative form of this periodic table. Now in this case, these are going to be elements of helium, neon, argon, krypton, xenon, radon, and oganesson. But I'm going to limit myself in our discussion to the all the other elements, excluding the last one in this particular case. Now, in this specific discussion, we're going to see that unlike the other elements from group 1 of the alkali earth metals or the alkaline metals, alkaline earth metals, the group 3 elements all the way to group 7, these are going to be one of the familiar groups of elements which are going to be exhibiting inactivity. In a sense, they are going to be referred to as inert elements. This is because their outermost energy levels have been filled and they have attained what we refer to as the octet of electrons. And this, of course, is going to be one of the characteristics which is going to be displayed by a number of these elements. But there's going to be an exception of these specific elements, especially which are going to show some slight reactivity. And these are going to be the elements of krypton and the xenon, and perhaps in our discussion I'm going to give a few compounds which are going to be formed from this particular element. Now we are going to look at different sources, properties, and some of their relevant application in our day-to-day lives, and that's going to be forming our final bit of this specific discussion. So I'd mentioned basically that last category of members of this particular group are going to be showing no reactivity, or their ability to form compounds is going to be, of course, limited. And in this case, we're also going to be looking at a few of them which are going to form compounds. Now, in terms of our sources, most of these elements are obtained from the atmosphere. And I mentioned in the constituents of air that atmospheric air is made up of various constituents, which of course include oxygen, nitrogen, carbon dioxide. There's element of gaseous water, which is going to be given as such, and there's going to be rare gases and some forms of impurity such as dust, etc. Now, in this particular case, we are going to see that one of the sources of this particular element, including helium, neon, argon, krypton, xenon, radon, some of them are going to be obtained from the atmosphere, but others we're going to see that there's going to be varying numbers of sources, especially from the Earth's crust, the sea, and other of course, sources which we are going to mention in this particular case. Now, the main sources of the first member of the first element of these specific groups, perhaps I can list them in terms of the helium, then we're going to have neon in terms of perhaps their atomic numbers. So we're going to have helium, neon, and then we shall have argon, 18, and then we are going to have krypton, 36, xenon, 54, and then lastly we're going to have this member of radon at 86. So most of these elements, as we have said, are going to be sourced from the atmosphere, which is going to form a major source of these particular elements in a sense. But the main source of helium, which is a first member of the group, so this is going to be obtained from natural gas. And of course, we are going to see that in this natural gas, it's going to be appearing in form or in the amount of 8% by volume. And one of the sources of this geographical location, in terms of geographical location, one of the sources of this natural gas is the United States of America, which is of course going to be giving this particular source of natural gas, and among other areas. Now, in particular, we're also going to look at some of the sources which are mentioned. And in terms of abundance in the universe, we're going to see that helium is going to form the second most abundant element in the universe. So the first one is hydrogen, as we had mentioned in our previous discussion. So therefore, helium is going to form the most abundant member of these specific elements in the universe, following hydrogen. Some of the properties of these specific members of the group 8 elements, as I've said, they are going to display, or some of the compounds which are going to be formed, of course, are not observed in this specific case, but we're going to see that the element of xenon and krypton, as I've mentioned, are going to be forming some of the compounds, and I'm going to give an example of some of those. So we're going to look at some of the important applications of various elements of this group 8, and that is going to assist us appreciate their specific relevance in our day-to-day applications, as I've mentioned. So in this case, for commercial use, we're going to see that the element of neon is going to be applied in discharge tubes, and a combination of argon and nitrogen are going to be used in advertisement light bulbs, and of course this is going to be one of the applications that we're going to come across of this particular element of group 8. And then I had mentioned about krypton and xenon. So these two elements are going to be used in lasers, flash lamps, and of course in photography, as we're going to see some of their compounds being used in this specific case. So I had mentioned that they are going to display some range of reactivity. So therefore, some of their compounds are going to be elemental form. They are going to be used in various applications in lasers. Going to be applied at used as a liquid at 0 kelvins. As a liquid, used as a liquid at 0 Kelvin. So this is going to be one of the most unique characteristic of this specific element of helium, which we are going to be, which is going to assist us try to, of course, find some of the applications in the medical field, which I'm going to mention later. Now, majority of the elements or all other substances are going to freeze at the and form solids at the temperature below 0 kelvins, and of course we're going to see that this is going to be a contrasting factor for helium, which is going to be liquid at this specific point. Now, also apart from that, the mixture of helium and oxygen are used in this deep sea diving, and of course we are going to see that this is due to the fact that this specific mixture is going to be applicable, especially in such a kind of an environment. And I've mentioned this one especially in our previous discussion on some of the applications of oxygen. And of course, we are going to also see that the element of this helium, which are the said, is going to be used in cryogenic. So perhaps I can just have this. So this in the medical applications, this specific element of liquid helium in large quantity is going to be used in cryogenic, of course, aspects. And these are metals that normally lose their electric conductivity at the liquid at helium temperature, which are given at 0 kelvins. And of course, this is going to become a superconductor and therefore find application in some of the devices in hospital, like the nuclear magnetic resonance and magnetic resonance imaging, which are essential devices, especially in the medical field. Now, this is one of the main, of course, application of this specific characteristic, which are said, whereby we're going to see that this specific temperature of 0 kelvins, most of the metals are going to lose their electrical resistance, and therefore they are going to be behaving as superconductors, and therefore they can be used in hospitals in these specific fields of nuclear magnetic resonance and magnetic resonance imaging are being used in hospitals. Now, sir, I promised there are some of the compounds which are going to be formed for the two, of course, elements of krypton and xenon. And perhaps I'm going to use to give some of the molecules formed by this specific element in combination with other, of course, compounds. For instance, if we have a xenon and the fluoride of platinum, we're going to have this one form a compound which is a yellow crystalline salt given the formula of xenon. So this is going to be given as such. So this is going to be particularly fluoride, so we're going to have this one. So this is a yellow crystalline salt. Now, in our discussion of various compounds of fluorine and their application, I just mentioned this one. Of course, this is going to be one of the compounds formed from the reaction between the fluoride of platinum and the xenon. And as promised, of course, this is one of the examples of a range of compounds being formed by xenon. Now, we can give other examples of compounds formed by this specific element of xenon. And these are going to be a range of compounds formed in combination with a fluorine or oxygen. So I can give this one in terms of this one. So we're going to have this specific compound formed, and xenon F4. So we're going to have a xenon 4F2. So this is oxygen, and then we shall have a xenon F6, and then we can have a xenon O3. And then we can have xenon O4. And then lastly but not least, of course, we're going to have H4 XaO6, which are a range of compounds which are going to be formed in combination with the fluorine or oxygen in this particular case. So these are going to be a range of molecules. For instance, the first one is going to be a linear molecule, whereas this is specific one for perhaps the xenon O4. This is going to be a tetrahedral a molecule, while a xenon F6, so this is going to be a tetrahedral. So we have looked at various structures of molecules. So this is going to be a linear, we can identify this one. So this is going to be a linear molecule, this is going to be a tetrahedral, and then we're going to have that one being an octahedral structure. But some of them are going to be distorted, like the last one which I've given in this particular case. So we're not going to go into details about this one, but of course it's good for us to appreciate that this specific element of group 8 is going to be forming some of the molecules which we have, of course, given as examples on the board. Now, that's one of the summaries of the group 8 elements which we are going to come across. But if we are going to look at them individually, of course, in detail form in some of our videos, then we're going to be introducing some of the new information which basically we might have not captured in this particular discussion. So kindly check our description boxes for various links of other videos. Engage us in the comment section, ring that notification bell, and also subscribe for more details on our various discussion in the topics under sciences and mathematics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.